So as Aaron said, I'm Adam Schneider. I'm from the U.S. Naval Observatory. I'm at our dark sky site, which is in Flagstaff, Arizona, so not too far from here. This will be a little different, but I have kind of a few major goals. The first one is to make sure that this audience knows that the UKIRT Hemisphere survey exists. So check. Um, I also want to tell you kind of what's in that survey, where it's going, what else is forthcoming with the survey, and then ways we're trying to improve it so that it might be useful for your science. So this is astronomy, so there's a few acronyms I need to get out of the way and acronyms within those acronyms. So UHS is the UKIRT Hemisphere Survey. UKIRT is the United Kingdom Infrared Telescope. That's a 3.8 meter located at Mauna Kea. It's infrared optimized, and it's got this big infrared camera with a large field of view called WIFCam that's really well suited for large near-infrared surveys. And so that's what it's been doing for many, many years now. There are several partners in this endeavor. There's USNO. There's also IFA at the University of Hawaii, the Cambridge Astronomy Survey Unit, and the Wide Field Astronomy Unit at Edinburgh. This started in 2012, so well before I got to USNO, but it's continuing to today, and so I'm taking over some of this effort. And it covers something like 13,000 square degrees in the northern hemisphere. I know Ruben's going to be down in the south, but the north might still have something to say. So the survey coverage looks like this. You'll see, maybe I can get a laser going. Down here, the different filters will kind of scroll by. It will start with J, which was the first filter that was done in the survey, then K, then H, then Y. It's kind of a time lapse, not a wavelength lapse. And so when it gets to J-band, that's what the full survey coverage looks like. And you can see kind of the completeness at different wavelengths as it scrolls by. You can always kind of see these maps. They're online. They're hard to find sometimes. So if you want to take a picture of that little website, you can kind of follow along the survey progress. The first thing you might notice is this beautiful mustard yellow color that they decided to highlight the survey area with. But the second thing you might notice is that there are kind of weird gaps in the survey coverage, right? It looks like some toddler took a cookie cutter to it. But that's actually on purpose, because those are where the previous UKID surveys have actually done work and they've been covered in the near infrared. So the idea is UHS plus UKIDs, you get pretty much continuous coverage at near infrared wavelengths between 0 and plus 60 degrees. Plus 60 is the mechanical limit of the telescope, which is really annoying, but we just can't get above plus 60. So we're looking at different ways to cover this northern cap at some level. But yeah, so these blue, red, and green are the main UKID surveys. Where can you, oh, okay. So the status so far is J-band has been released. That was done in 2018, so you can find that online. You see the median depth there of 19.6 magnitude, so that's 3 or 4 magnitudes deeper than 2MASS, so there's quite a bit of discovery space there. K-band release was happened just last year, so it's been out for about a year now. And again, 3 to 4 magnitudes deeper than 2MASS. And combined with J-band and K-band, the number of detections is getting close to about 1 billion detections. So it's a fairly deep survey. H-band is ongoing, so we are about, it says 95% complete. There's still some QC that needs to be done, so I expect that number to continually drop down as we get closer and closer to 100. But it's something like 80 to 90% complete right now. We expect that release to come out next year sometime, so not too far away from our H-band release. And then we're doing Y-band and a second epoch of J at the same time. So you can see in the previous plot that had kind of the one survey that was just getting started, that's Y-band and second epoch J. And we're about 10% complete. You know, it would take a few years to get that survey done, but that'll be a nice long time baseline between the first epoch of J and the last epoch of J. Where is it? It's at the WIFCam Science Archive. If you're familiar with this archive, that's great. You can find the website here. One of the quirky things is you have to pick UHS here and here if you want to search for UHS, either images or catalog data. It will let you pick UKIDs and then UHS, and you can do that search. You'll find nothing because it's meaningless. So you got to make sure and put UHS in both areas, or else you won't get UHS data. But there's images there. You can get all the images, and then there's the catalog with all the photometry is available on the WIFCam Science Archive. So the way the process works is USNO is kind of running the survey. We define all the observations and we send all that in. Observations get taken in Hawaii. They all get sent to our UK partners who have made the pipelines for a long time, doing UKIRT's data of reducing all the data and making a nice catalog. The issue, quote unquote issue, is that those pipelines are the same pipelines that they've been using for UKIDS for a very long time. And so they're astrometrically calibrated to 2MASS. And 2MASS itself is calibrated to Tycho, and we can do much better than that now with Gaia covering most of the sky. So one of the efforts that we're doing at USNO at this moment is recalibrating all of the UKIRT Hemisphere survey detections against the Gaia reference frame. And so these are kind of the astrometric improvements that we get when we recalibrate against Gaia. So at the top here is J, this is K-band detections, and these are Gaia offsets. Oh, sorry, there's another acronym. NOFS is the Naval Observatory Flagstaff Station. So that's the Naval Observatory essentially. So that's the green. And then the offset you'll get from just the catalog search on the WIFCAM Science Archive is WFAU. You can see the offset is quite a bit. So the bottom line here is we're going from something like offsets of 50 milliarcseconds to less than 10 generally for our recalibrated data. We're not just getting new positions. So because of the sequential nature of the survey, J-band was done first and then K-band started sometime in 2017. There's a median epoch between the areas that get covered of about 5 years, so we can get proper motions from this, which is really nice. I like proper motions. So one of the first things I wanted to do is see how good are these UHS proper motions? How good is it compared to essentially other surveys that might also be doing proper motions? And my subfield of science is substellar objects, so I'm going to go ahead and check out all the known brown dwarfs in the UKIRT Hemisphere survey and see what kind of proper motions we can get for those objects. Sarah introduced the brown dwarfs a little bit, but just to remind you, they're objects between stars and planets. And for the purposes of this, they're perfect because they're faint infrared point sources, but sometimes they have high proper motions because they can be nearby. And they have spectral types of L, T, and Y. So if you're familiar with OBF GKM, it continues to L, T, and Y, and those are the brown dwarf spectral types, essentially. So this histogram down at the bottom shows the histogram of all the spectral types, excuse me, of all the brown dwarfs in the UKIRT Hemisphere survey. There's about 1,000 total that we found, and we measured proper motions for about 800 of them. That's a function of not having the same exact survey coverage in J and K band, and then also you can see as you get to later spectral types, the SEDs behave in such a way where you can get a J-band detection and K-band coverage, but not get a K-band detection, so you can't get a proper motion with one detection. So over on the right are comparisons with 3 kind of prominent surveys that do proper motions. We've got Gaia on the top. This is CatWise in the middle here, and this is work from Will Best in 2018, who used pan-stars to get proper motions. Don't worry too much about the histograms. What's really relevant here is the comparison of the precision of the proper motion measurements. And this 1-to-1 line over here on the right side, if it's above that line and in red, that means the other survey got essentially a better measurement. And if it's below and in blue, that means we did better. So we don't beat Gaia, which is kind of expected. Gaia is pretty good at astrometry. But you can see in the cases of CatWise or pan-stars, we almost always do better than those surveys. So the bottom line here is if you have an object that's in the UHS footprint that's not in Gaia, the best astrometry very likely will come from the UKIRT Hemisphere survey. Okay, so now I'm going to talk about some of what I consider the rare gems in this kind of data, which are the brown dwarfs. And so Sarah introduced Backyard Worlds in her talk, which is great. I've loved seeing so much citizen science here at this meeting in general, but this is an object, CYS 0506, that came to us through the Backyard Worlds collaboration. It was submitted as an object of interest, and it was one that I initially started following up and didn't have a lot to go on. It's very well detected in WISE, but it's not in pan-stars. There's a low signal-to-noise detection at K-band and 2MASS, and it's not in 2MASS J. But UHS found it pretty easily. And this one was tricky because the proper motion wasn't really high. So, this kind of looks like an AGN to some of us. and, if it's not moving and it has those colors, we've been fooled before. So UHS gave us a nice proper motion of significance. Thank you. And the nice thing about the J-band detection, which is clearly much deeper than 2MASS could get, is it allowed us to put it on color magnitude diagrams. And so this is it in this blue diamond compared to the known brown dwarf population. So this is well outside what we thought existed already. We thought we had found most of the weird outliers, but this one was an outlier amongst the weird outliers. We got a spectrum with Keck, and we thought it would be weird, and sure enough, it's weird. It's really red, kind of confirming the color. We don't need to know too much about this. We think it has methane, which is really interesting for this kind of object. Also, shout out to the citizen scientists here who helped discover this object. That's who they are and where they're from. But what we think this is a really low gravity, young brown dwarf that's extra cloudy, and that's why it has so much redness to it. But it's also like 5 to 10 Jupiter masses out there kind of floating on its own. So it's one of these free floating planetary mass objects that some people like to call planets. I just call it a brown dwarf that looks like a planet a bit. But for me, the real treasure trove, so to speak, in the UHS data has been the Hyades. I like to start with this picture because this is the very first map of the Hyades I could find in an astronomical journal, and I love it. I want to show it more often. This paper by Wirtz has 2 citations. It's about to get a 3rd. But just to show how far we've come, right? The first maps of the Hyades had a few dozen objects. And now with Gaia, we know that there's the stellar population has been completely mapped out in great detail. And we even see these long tidal tails going in each direction, which are amazing. And, things like Gaia helped us out. But for me, it's perfectly placed in the sky, distance-wise and area-wise, because it's in the northern hemisphere. So we've got it with UHS. But it's just far enough away that Gaia stops right at the stellar substellar boundary. Can't find any brown dwarfs. So there's room for me. And I should mention that when it comes to brown dwarfs in the Hyades, it's not clear that there should be a lot there because dynamically, there's this idea that they may have scattered over the age of the cluster and not be there anymore. So, we can help test the dynamical history of the Hyades if we find more brown dwarfs within it. So in 2022, we followed up our first 7 candidates that we found in the UHS survey. And this is not a complicated process. We are finding non-Gaia objects with Hyades-like proper motions in the infrared and following those up. And we found 7 new brown dwarf candidates. It doesn't really matter the spectral types, but L5 to T4 if you're interested in things like that. And so we found the gray here is the Gaia catalog of nearby stars, census of the Hyades, and this is just the core where we're focusing. There are known Hyades, L and T dwarfs, and then we found 7 new ones. We're about to publish 8 more, so this is approximately submitted. I thought I would get it by the time of the conference, but it's out with the co-authors right now. So we have 8 more spectra that we just got in the last observing cycle. Thank you, Gemini, for the time. And again, there are some oddballs in here, but we think we can explain most of it. But 15 new potential brown dwarfs in the Hyades in the last few years is essentially doubled our number of Hyades candidates. And people have been looking for Hyades brown dwarf candidates for decades now. So we're really kind of filling this out. And so this is the full Hyades color magnitude diagram from the highest mass members up here. This is, oh, what was that? Sorry. This is all Gaia data, and then the known brown dwarfs, and then there's the UHS contribution. So we're really starting to fill this out. I'll leave a summary up here. And there's 2 things I want to mention real quick. So we talked about recalibrating the UHS data against Gaia. Something we want to do now, too, is go back and recalibrate all the UKIDS data against Gaia. So that's all, the whole northern hemisphere from 0 to 60 is all on the same reference frame. Yeah, and so when it comes to people at USNO that are digging in and data mining all of the UHS data, you're looking at that person. So I'm focused on one particular set of objects. I'm sure there are many more science cases that are useful for the community. So hopefully you can find some use there. With that, I'll take questions.